UTME is in a few weeks now, and a lot of tension is in the air as to which topic to really study for those that haven't started their preparation very well, and as to which topic that you must really know, you must really understand. In this video, I'll be pointing out topics from which questions are always asked in physics for the UTME. So my name is Belumi, a second year medical student. I post educational and self-development content. So if you're up for it, kindly hit the subscribe button and then hit the notification bell. Get updates as I drop new videos on these said areas. And the English meaning of my name is follow me, so kindly follow me and subscribe. Before I start, I would like to emphasize on something, and it is that if you have the opportunity to actually cover the entire topic, please kindly do so. This is just an alternative should you not be able to cover the entire syllabus before you examine it. So you can resort to this only if you are unable to cover the entire syllabus. And the first topic is measurements and units. Under measurement and units, we have physical quantities, we have dimensions. Now, under measurements alone, we know we have measuring devices, like for length, for time, for mass. Measuring devices for length includes the meter rule, the vernier caliper, the micrometer, screw gauge. For time, it includes quartz crystal clock, atomic clock, sand clock, stopwatch, which is the one that is usually used in the library. That's the standard one for physics. While for mass, we have the beam balance, we have the lava balance, we have the chemical balance. Now, we also have something we call spring balance. Now, spring balance is not used to measure mass, it is used to measure weight. Please kindly take note of that. And it's very important for you to actually know the reading accuracy and then the smallest division of each of those measuring instruments. Like the reading accuracy of meter rule is 0.5 millimeter. So it's very important for you to know the reading accuracy, the smallest division on each of those measuring instruments. And from there now we can go to physical quantities. We know that physical quantities are divided into two. You have the fundamental and you have the derived. Now the fundamentals are 9, or basically your new school physics will tell you that it is 7. You have the mass, you have the length, you have the time, you have the temperature, you have amount of substance, you have electric current, and then you have luminous intensity. And then you need to know their unit as well. So those are the fundamental quantities. Now, your derived quantities are all other quantities aside your fundamental quantities. So it's very easy for you to actually know that. And now let's go to dimensions. So you need to understand dimension that, in fact, that dimensions can actually help you to actually figure out the formulas. Let's say you are given, let's say your units in your options now is meter per second square, and you are given meter per seconds. One of the parameters you are given to calculate the answer you are looking for is meter per seconds and seconds. What are you going to do? That means it has to be what? Meter per second divided by seconds. That will give you a meter per second square. So that correlates with the units in your option. So knowing dimensions actually goes along with it. It helps you to actually be able to figure out some things. So the first topic is measurements and units. Now it's very important for you to actually follow your syllabus anytime you're trying to study these topics. There's the syllabus will always highlight it. Candidates should know, candidates should be able to. So once you're able to follow that, I can assure you that you won't have any problem. So start with measurement and units and check your syllabus to actually correlate with it. Now the second topic is scalars and vectors. Now scalars and vectors are always there because scalars and vectors are actually related to a lot of topics like gravitational field, electric potential, magnetic field. So and forces as well. So if you're able to understand physical quantity, if you're able to understand scalars and vectors, you'll be able to answer questions under gravitational field, electric field, and all field forces generally. So, and you know, under scalars, we have scalars. Scalars are the ones that don't have direction, they only have magnitude, while vectors has both direction and magnitude. And there's a way that you usually add scalars and vectors together. There's a way you add scalars and vectors together. For scalars, you just add them directly because they only have magnitude. While for vectors, they have both direction and magnitude. So you have to consider the direction when you're making the addition. And under vectors too, you have ways of actually adding vectors together. You have Lami's theorem, you have parallelogram method, you have basically ways of adding vectors together. You have analytical method and geometric method. Analytical method is you breaking them down into x and y components, while geometric is just you using parallelogram method or Lami's theorem or Pythagoras theorem in short. Using Pythagoras theorem or parallelogram method. That's for geographic. And from there, you need to understand relative. Now you need to understand relative velocity also. Now the way you add the way you add vectors together is different from the way you determine your relative velocity, because relative velocity basically has to do with perception. You are moving for scalars and vectors. If you have two vectors going in opposite direction like this, you have two vectors going in opposite direction like this, their resultant will be this minus the magnitude of this because they are going in opposite direction. But then for relative velocity, if you are going in opposite direction, you have to add their magnitudes together. So you need to take note of that. So the second topic is scalars and vectors. Just be able to check your syllabus check your syllabus to actually correlate it to make sure that you don't miss any point, because it's very important for you to actually know that side where the candidate should know. Don't focus on the side of the whole topic outline, just focus on candidates should know. It will be very good for your revision. Now, the third topic, this topic is, once I tell you this topic, you definitely, you won't argue it. The topic is motion. There is no way you won't be asked motion in any question, except if, I don't know, but mostly you always ask motion. Now, the third topic is motion. Now, motion is always asked. And under motion, we have types of motion. Then take note that circular motion is not the type. Let's say you forget a particular, let's say you forget the formula for you to calculate a particular quantity. Now, the way you can do it is from the units of in your options, you can easily do more like a reverse, trace it back, so that you'll be able to, okay, if, let's say you are given, let's say your units in your options now is meter per second square, and you are given meter per seconds, one of the parameters you are given to calculate the answer you're looking for is meter per seconds and seconds. What are you going to do? That means it has to be what? Meter per second divided by seconds. That will give you a meter per second square. So that correlates with the units in your option. So knowing dimensions actually goes along with it. It helps you to actually be able to figure out some things. So the first topic is measurements and units. Now, it's very important for you to actually follow your syllabus anytime you're trying to study these topics. There's the syllabus will always highlight it. Candidates should know, candidates should be able to. So once you're able to follow that, I can assure you that you won't have any problem. So start with measurement and units and check your syllabus to actually correlate with it one another. Now, the second topic is scalars and vectors. Now, scalars and vectors are always there because scalars and vectors are actually related to a lot of physics. Because scalars and vectors are actually related to a lot of topics like gravitational field, electric potential, magnetic field. So, and forces as well. So, if you're able to understand physical quantity, if you're able to understand scalars and vectors, you'll be able to answer questions under gravitational field, electric field, and all field forces generally. So, and under scalars, you have scalars. Scalars are the ones that don't have direction, they only have magnitude, while vectors have both direction and magnitude. And there's a way that you usually add scalars and vectors together. There's a way you add scalars and vectors together. For scalars, you just add them directly because they only have magnitude. While for vectors, they have both direction and magnitude. So you have to consider the direction when you're making the addition. And under vectors too, you have ways of actually adding vectors together. You have Lami's theorem, you have parallelogram method, you have basically ways of adding vectors together. You have analytical method and geometric method. Analytical method is you breaking them down into S and Y components, while geometric is just you using parallelogram method or Lami's theorem or Pythagoras theorem in short. To understand relative velocity also. Now, the way you add the way you add vectors together is different from the way you determine your relative velocity, because relative velocity basically has to do with perception. You are moving for scalars and vectors. If you have two vectors going in opposite direction like this, if you have two vectors going in opposite direction like this, their resultant will be this minus the magnitude of this because they are going in opposite direction. But then for relative velocity, if you are going in opposite direction, you have to add their magnitudes together. So you need to take note of that. The topic is scalars and vectors. Just be able to check your syllabus. Check your syllabus to actually correlate it to make sure that you don't miss any point, because it's very important for you to actually know that side where the candidate should know. Don't focus on the side of the whole topic outline. Just focus on candidates should know. It will be very good for your revision. Now, so the third topic is motion. We all can agree that motion is always asked in question almost every single year, and the questions that you always have that are always extracted from motion are up to like 4, 5, 6. So imagine you getting all the 4 or the 5 questions. That would definitely boost your mark. Motion, you now have types of motion, which includes oscillatory motion, random motion, and the rest. Now take note that circular motion and linear motion are not types of motion, they're just forms of motion. And under motion too, you have two aspects of motion. You have the kinematics and then you have the dynamics. Now the kinematics is the one that deals with study of the motion itself, like the velocity, the acceleration, while dynamics is the one that studies what causes the motion, which is force. So that you have types of forces and the rest. So, and then under motion, you have to also know the graphical representation of all the motions, like velocity time graph, acceleration time graph, distance time graph. Then you can now go to projectile motion. Now, projectile motion is one that deals with parabola pathway. Now, take note that it's not just the one that deals with parabola pathway. It can also be what our parabola. Like for example, when you are throwing the ball from the top of the mountain. Let's talk about the parabola pathway. Let's talk about the one that has to do with parabola pathway. You need to know the formula for calculating the total time of light. You need to know how to calculate. You need to know the formula for calculating the range, and then the maximum height. Now, under the dynamics part, then you can now talk about Newton's law of motion. You know, you have three Newton's law of motion. We have the first one, which said a body in motion or at rest always tend to resist any change in its state. So if a body is at rest now, it always wants to rest. If you are trying to make sure that make it move, it always resist that change. If a body is moving already and you want to stop it, the body always tends to resist that change. So that's what the first law is about. Then the second law is one that's the rate of change of momentum is the same thing as your force applied. While the third one is the one that talks about action and reaction. For every action, there is an equal and opposite reaction. We can now talk about circular motion. Now, under circular motion, you have your angular velocity, you have your angular speed. Take note that angular speed and angular velocity are quite different. Angular velocity has direction, while angular speed does not have any direction. Now, although the magnitude of angular speed and angular velocity are the same, does that what the difference is in the fact that one of them has direction while the other one does not have direction. And then you have your angular acceleration, you have your linear velocity, you have some other aspect of it as well. Now you can calculate your angular velocity in radians as well too. So, and even calculate in radians, then you have to take note of the angle of the circle, which is 360 degrees and rest. That's the way you do all the calculations. So make sure you just check your textbook and see how the breakdown. And then from there, now we have simple harmonic motion. Now for simple harmonic motion is has to do with, for example, a simple pendulum going to and fro. And I think the main criteria for a body to undergo simple harmonic motion is that the acceleration must be directly proportional to the displacement, even though it might be in the opposite direction to it. Now what that means is I'll use the case of a simple pendulum, for example. Now for simple pendulum, we have a pendulum bulb attached to a rope. Then you displace it towards one side. Now the displacement is usually from the center, from the on the stop position, which is the equilibrium position, to the point where the motion starts. So you release it will go down, go to that equilibrium position, go back up, come down, go back up. Now for that, you have your length, you have acceleration to gravity, because acceleration to gravity will be acting on the ball, and then you have your, what's it called? You have your period, you have your frequency. Now the relation between your period and your frequency is period is equal to 1 over frequency. And take note that for your frequency, for any formula for calculating your frequency, the way you can actually notice, know that for frequency, the constant is always on top. Like the formula for calculating frequency of simple pendulum now is F equals 1 over 2 pi root G over L. G there is actually to gravitational, and that's the constant. You know what I'm saying? So, and you have for mass spring too. You have for a spring, you have for loaded test tube and the rest. So make sure you check your textbook for all that. The fourth topic is equilibrium of forces. Now equilibrium of forces is more like, it's very related to vectors. The fact that for the only difference is that for equilibrium of forces you have your equilibrant instead of your resultant, and your equilibrant is in opposite direction to what your resultant. So if you're able to calculate your resultant, just retain the magnitude and just reverse the direction. Like for example, if you have something like northeast, then you can change it to southwest in the case of your equilibrant. So that's, and under equilibrium, you can use Lami's theorem too for equilibrium of forces. You use Lami's theorem for equilibrium of forces. What other aspect of equilibrium of forces is there? Basically, what I said is under vectors. So far you can understand vectors very well. Calculating equilibrium of forces is very easy. Oh, then the under linear mode, under. Okay, that's not it's not there. Is it under equilibrium of forces or under work energy and power? Okay, I'll still talk about it. Sure. But then let me just say it under motion. Let's say an aspect about momentum. You know, momentum is what? Your mass times your velocity. And there is this principle of conservation of momentum, which is that the sum of the momentum before collision is equal, almost equal to the sum of momentum after collision. And then we have different kind of collision. We have elastic and inelastic. We have all of that too, but then these are the main ones. Now for your elastic, both the momentum is usually conserved, and then the kinetic energy also conserved. While for inelastic, usually the momentum that is conserved, the kinetic energy is not, the total kinetic energy is not conserved. That means the kinetic energy before collision is usually different from the kinetic energy after collision. So that's under momentum. And so let me go back to equilibrium of forces now. Now for equilibrium of forces, as I said before, you need to understand Lami's theorem. If you understand addition of vectors very well, you won't have any problem with equilibrium of forces. Now the next one is work energy and power. As simple as this topic may seem, it's always repeated. It's always repeated. It might be related to, it might be joined together with motion, but then it's always asked. Now, work energy, you know your work is what? Product of force times parallel distance, not perpendicular. Now, perpendicular distance is that of what moment, which is, we are still going to go into that. While your energy is, you have different type of energy. We have the potential energy, you have kinetic energy, which are both of them are grouped together as mechanical energy. You have your solar energy and the rest. Now, there is this principle of conservation of energy. You say that was energy can neither be created nor destroyed, but it can only be converted from one form to another. So you might be asked questions on this energy in such a way that they will link it to simple harmonic motion. Like in the case of simple pendulum that I was talking about. Now, as the simple pendulum is moving to and fro, it has an energy. At the equilibrium position, it has potential. It has zero energy. It has zero potential energy. Now, once you displace it to this side, to one side, it builds up potential energy. Now, when you release it, the potential energy reduces, but then the potential energy is now being converted to your velocity, to your kinetic energy. So that as it's moving from the highest point to the equilibrium position, the potential energy is being converted to what? To kinetic energy, and the kinetic energy is always maximum at the equilibrium position. So physics is what? It's still in motion, it's moving to and fro. So that's where you can link energy to simple harmonic motion. And then for power too, you know your power is what? Rate at which you can do work, rate of doing work. So that means is what? Work done or energy transferred over time. There are a lot of ways we can actually link all these things together. But then I'll quickly talk about moment of forces too, because you might be asked that. Now, moment of force is what? As I said before, is what? Force times perpendicular distance from the line of action of the force to the pivot. Now, that's why you always have, like, they would always say that a uniform meter rule is pivoted on so. Now, what I'm basically concerned about now is you should be able to identify your pivots. You should be able to identify where each of those forces are placed, and then you need to identify the distance from where those forces are acting to the pivots. Now, there are some questions that you might be asked for two pivots, so I won't really be able to talk about that because I want to make sure that this video is very short. So go through your textbook and see. So just make sure that you go over moment of forces as well. Moment of forces, the one about a single pivot and then two pivots. And then the sixth topic is friction. Now, you know, we have types of friction. You have static friction, you have dynamic friction, or kinetic friction. And then take note that your static friction, the quotient of your static friction or your static friction value itself, magnitude, is always greater than your dynamic friction or the kinetic friction or its coefficient as well too. And you need to know the laws of solid friction. Now, take note that we don't just only have solid friction. We have liquid friction as well. So that's viscosity. We are still going to just go by the. We are still going to go there as well too. So make sure that you reverse frictional force. All those areas that I talked about, how to calculate coefficient of friction. Coefficient of friction is equal to frictional force over the normal reaction. So you need to actually go over your textbook and take note. Check your syllabus to correlate the must know with what is in your textbook, so that you make sure that you know the necessary stuff. I have liquid at rest. Now, liquid at rest is the aspect about hydrostatic pressure and viscosity, surface tension, and all these other parts. So make sure you read that before you go for your exam as well. Then we have thermal physics. Now, thermal physics is always broken down into series. You have the part about temperature and its measurements. Then you talk about Kelvin, Celsius, and Rankine. Now, take note that Kelvin is more like the basic unit for measuring temperature. Take note. Anytime you're dealing with anything with temperature in physics, make sure that you're always converting whatever stuff you are given to Kelvin. Then you have its measurements too, like liquid in glass thermometer, gas thermometer, thermocouple, and the rest. So make sure you read all those topics. Just read it. Just make sure you touch all those parts. And you have the part about calculating latent heat. You have the part about calculating specific heat capacity. You have the part about calculating its capacity, and then you have the part about what's it called? Now, the way they always link power with thermal physics as well. When you talk about you are trying to heat a liquid, you are trying to boil the water using a heater. What will be the time taken for the water to boil to so temperature? Now, they give you the power of the heater, and then they will give you the mass of the water, and then they'll give you the specific heat capacity of water as well too. So the way they always tend to link it together. I would advise that you solve questions on this so you will be able to relate with it. And then the ninth topic is wave. Now, on that wave, you have types of wave. Now, there are classifications of wave based on the medium required. Like for example, you have two under that. You have the mechanical wave, and then you have the electromagnetic wave. Now, based on the direction of propagation, you have two as well. You have the transverse, and then you have the longitudinal wave. And then based on the transfer of energy and the movement of the wave itself, you have stationary and progressive. Now, take note that waves generally transfer energy from one point to another, and then the particles do not move from that point to another. They just vibrate up and down around the point. And then you need to know about the mathematical representation of progressive wave too, where you have y equals to a sine omega t plus or minus. I can't remember the remaining, but you need to know the mathematical representation of waves as well. And then what other part of wave? Then you need to understand sound waves. You need to understand the sound wave. You need to understand what else? You need to understand the overtone, harmonics. You need to understand frequency of a wave, wavefront, and the rest. So just make sure that you touch waves properly. And then the 10th topic is optics. Now under optics, you have concave lens, you have convex lens, you have parabolic mirror, you have concave mirror, you have convex mirror. Now under that, now you need to know the mirror formula as well too. You need to know the mirror formula. You need to know where images will be formed at the back. You need to know where exactly images will be formed when an object is placed so distance from the object. You need to know how to calculate that. You need to understand. You need to know all the formulas. You need to know optical instrument as well. So like the Galilean telescope. You have the Galilean telescope. You have the simple microscope. You have the you have a lot of them. You have this thing kaleidoscope too. You need to know that one too. You need. I can't remember the name of this thing that is used to check, that is used to see enemy around the barrier. I can't remember the name. If you can remember the name, you can just drop it in the comment section. So you have all of that. So you have to really understand optics itself very, very well, because you always be asked. And then the 11th topic is electricity. Now electricity is divided into two parts. You have the static electricity and then you have the current electricity. Now under static electricity, that's where you have your electric field. You have the charge itself, where you talk about electroscope, for which is used for charging, for detecting the type of charge of the nature of the charge on the charge. That's funny. The nature of the charge on the charge. And then you have the electric field. Under electric field, you have electric potential, electric field strength. Now, I think that electric field strength, electric field intensity, and electric field itself alone, all of them are all the same. It's the same formula used to calculate all of them. And then it's very important for you to note that electric field basically works using Coulomb's law. Now, Coulomb's law is one that states that two charge and the force of attraction between two charge is probably proportional to the product of the charge and inversely proportional to the square of the distance between them. So you need to know all those as well. So then you go into current electricity. Under current electricity, you have electric current itself. You have your potential difference. You have your Ohm's law too. Don't forget your Ohm's law. You have your Ohm's law. Then you have resistance. You have capacitance. You need to know how to calculate your resistance in different coordination, both in series and in parallel. Same thing for your capacitance as well too. So take note of that. You have two aspects of electricity, and you really need to understand the two aspects properly. Now, the 12th topic is gravitational field. Gravitational field is very similar to electric field, but the only difference is just that gravitational field has to do with mass, while electric field has to do with what's charge. So under gravitational field too, you have your gravitational field strength, gravitational field intensity, you have your gravitational potential, you have your gravitational force itself, and your gravitational force can be calculated using Newton's law of gravitational force, which says that the force of attraction between two mass is directly proportional to the square of the product of the individual masses, and inversely proportional to the square of the distance between the two of them, almost similar to that of Coulomb's law. Just that you are just changing the charge to mass, point mass. So you need to know that as well. You need to know how to derive the formula for calculating your gravitational field, your gravitational potential, and then you need to take note of the energy change that occur because the gravitational potential is the work done in bringing a unit charge from infinity to a point. So you need to know how to calculate the work done in moving a body of mass from one point to another too. So make sure that you go over gravitational field. And then the last one, which is the 13th topic, is modern physics. Now under modern physics, that's where you have your radioactivity, you have your radioactivity. What else do you have? You have radioactivity, you have electronics too. Under radioactivity, you have your half-life, the name of the person that all this Marie Curie, Père Curie, you have your neurons, you have your barons and the rest. So make sure that you treat it and know how to calculate your half-life, know how to calculate the number of atoms left after the time of decay. And then for your electronics, you need to know your NP transistor, all these NPN diodes, you need to know all of them properly. So I think those are all the topics that are always asked in physics, in UTME for physics. So if you find this very helpful, kindly hit the like button and share with your friends that are preparing for UTME as well. So I actually don't want this video to be very long, but then it got long.